So good evening, friends. Today I discuss the one problem now in this lecture. So the question is that derive the formula of time period of the simple pendulum, if at all the time period of the simple pendulum depends upon mass of the pendulum, length of the string, and gravitational acceleration. You cannot expect these kind of questions in the competitive examinations, but this is basically for the CBSE, NCERT board examinations or some kind of that kind of stuff. So it's a subjective based question. So let's see the answer. It is something like we'll write the proportionality. Yeah, you can see that workout in the next slide. So I'll show you the next slide how the workout would be. So here we go. So this is a solution. So how do we solve this question? So solution, so we can say that the expression T would be, so we can say that the expression T would be in this form. The time period is some number which is called the proportionality constant multiplied by mass to the power A and length to the power of B and G power C. Like this we'll write first. So T is actually, you can write the proportionality itself like M power A into L power B into G power C. Like this you can write, one can write like this. And now what is this T? T is a time period, right? So it is there is no mass involved, no length is involved, and then the time has having the dimensions of 1, and that should be proportional to some number which is having the dimensions 1. So that number is anyway not going to come in the picture, and then this is the mass to the power of A. So that is M to the power of A into L power B. And whereas the acceleration due to gravity, how does that work? So that is L T power minus 2. That is the acceleration dimensions, that is gravity. So that is power C. So let us write this is M power A into L power B into L power C into T to the power of minus 2C. Like this you can write. So this is proportional to M power A into L power B plus C multiplied by T to the power of minus 2C. And now here you can say this, you can compare the powers like power up for the mass dimensions, you can compare with the power for the mass dimensions. Power for the length dimensions, you can compare with the power for the length dimensions. Power for the dimensions, you can compare with the dimensions of the time dimensions. Okay, power to the time dimensions, you can compare with the power to the dimensions on the left side as well as right side. So once you do that, you will arrive to these numbers A equal to 0. So you can understand that A here, M power A here, and M power 0 is here. So you can compare this A equal to 0. Like this, you can arrive A equal to 0. And from this L power 0 is there, and here on the right side L power B plus C is there. So you can arrive to the number B plus C should be equal to 0. That is fine. And again here T power minus 2C is there, and here T power 1 is there. So minus 2C can be equal to 1. So C can be minus half. You can arrive to this conclusion that C can be minus half. So that is what is arrived over here. C is minus 2C equal to 1. So C is minus half, and B is half, and A is equal to 0. Because B plus C should be 0 and C should be minus half. So T is equal to some number multiplied by M power 0, L power half, and G power minus 2. This is how you arrive to the numbers. So here it's minus half. Please note it's minus half. Now here this is T is equal to some. So you can write this M power 0. So mass is not involved. L power half into G to the power of minus half. That means L by G whole to the power of half. You can write like this. L by G whole power half is nothing but root of L by G. So that is how you can write. The quantity is some number, whatever is there can be found from an experiment. Okay, the quantity this number you can find it by using some by the means of some experiments. You can come up with this number. So they derived this number to be like 2 pi. They got this number by 2 pi, and measure the length of the pendulum that can be found by experimentally. The quantity, that number, whatever proportionality constant is there, can be found by experiment. Can be found by experiments. So measure of the length of the pendulum and oscillate it. Measure the length of the pendulum and oscillate it, and find its time period by a stopwatch. So that is the experiment you can conduct. So it's like you can take a simple pendulum and you can drop, this is the bob of the simple pendulum, and then make it oscillate. Okay. Okay. And this, the to and fro motion you can measure by using a stopwatch. So when you do that, you can understand that it doesn't matter whatever the weight of the bob is. That's the beauty of this particular experiment. The time period of the simple pendulum does not depend upon the mass of the bob. So that's very important. That's experimentally proved also. Time period of simple pendulum does not depend upon the mass of the bob. So this is what the conclusion you can make. This is a very, very important point. You can make a note of this also. So if at all you want to make a note on these things, you can pause the video and then make a note. So here you go, and suppose this is the considerations what the experiments taken. This is L is 1 meter. You get T is equal to 2 seconds. So for the small oscillations, okay, T is equal to 2 seconds is what we get. And so this 2 is equal to some number multiplied by 1 by the value of G is 9.8. So that some number happens to be 6.28. So that 6.28 ultimately, if you work out that, that is the value of 2 pi. Okay. So that the experimentally this is so 2 point, you may have the idea that the pi value happens to be 3.14. So 2 pi happens to be like this approximately 3.14 approximately. So it's 6.28, right? So this is the value they got it, and then they accustomed this experimentally. They found that this constant is 2 pi. This now this sum number, the proportionality constant, they got it as 2 pi by doing several experiments. So thus the time period of the simple pendulum is given by the formula T is equal to 2 pi into square root of L by G. So this is how one can derive. So first we will use the dimensions and derive the formula, and then later we derive the proportionality constant by using some experiments. Experimentally, the proportionality constant can be determined. Experimentally, you can determine the proportionality constant. So hope you like the video, and this is where I conclude the video. And then I hope you like the video, and please give a like and subscribe and share these videos. And then it's very useful. I discuss right from the basics of the physics to the advanced level. And thank you all. Thanks for your support, and hit a like and subscribe if you like the video, and then share it with your friends. I need all your support to make further videos and to help you more. Thank you all.